And here you have it, a metal part sliced with the new Ultimaker Cura 5, printed on an Ultimaker and post-processed into a final metal part. Hi everyone, my name is Marit Hofmans. I'm a product marketeer at Ultimaker, and in the next couple of minutes I would like to talk to you about metal FFF 3D printing. For those of you familiar with metal printing, you may know that printing metal parts with Cura and an Ultimaker printer is already possible. However, with the release of the new Ultimaker Cura 5.0, we take a big step forward in making metal FFF printing easier and more successful. This means that you can create high-performance parts with the advanced properties that metal has, such as an extremely high strength or temperature resistance, allowing you to print applications that are often not possible in using plastics. So, how do we achieve this with Cura 5? As explained earlier by Mariska, the new Cura 5 comes with big improvements for creating detailed and thin parts. This is not only relevant for plastic parts, also metal applications will greatly benefit from this. With the new Cura improvements, metal parts with thin walls will benefit from an increased wall stability. This is very important for these parts because it will help to minimize the chance of delamination during the post-processing steps, and thus it will contribute to a successful end result. But next to the general Cura 5 improvements that metal parts will benefit from, we're adding more. We will introduce specific features and settings for metal printing that Ultimaker users that print with BASF Forward AM UltraFuse 74pH and 316L metal filaments will directly benefit from. These new features will make the slicing workflow for metal printing easier and give you more control over the outcome. So, what are these new features exactly and how do they improve the printing of metal parts? For this we will move to our experts, who both have been involved a lot in metal FFF 3D printing. Welcome.
Sure, Marit. Thanks for the introduction. My name is Andrea, and I'm part of the product management team and leading the metal printing initiatives within Ultimaker. Here with me today is Tobias.
Hello, my name is Tobias. I'm the business development manager for our UltraFuse metal filaments working for BASF Forward AM.
No doubt that producing metal parts by standard FFF technology is coming out strong as a high interest topic from the 3D printing adopters globally. For those that are still not familiar with the process, extrusion-based metal printing rely on the processing of highly filled metal filaments, like the ones offered by BASF Forward AM, to produce a green part that is subsequently debinded and sintered to finally obtain a near net shape and full metal part. The sweet spot for this technology are the thousands and thousands of customized tools, manufacturing aids, and obsolete non-critical components. When operating the technology within this sweet spot, user can potentially realize cost savings up to 90%, lead time reduction up to 70% for small series. However, metal FFF on open systems like Ultimaker is still in its initial stage of development, and more is needed to reach the level of readiness to fully enable a flawless and reliable metal parts printing process. The path towards the needed level of process performance and quality involves development on all fronts: hardware capabilities, material, but also software capabilities. And here today I'm really in particular referring to the print job preparation by means of a slicing software like Cura. Many of the benefits that the introduction of the new engine in Cura 5.0 are definitely applicable when dealing with printing metal parts. Being able to print sharp corners and stable thin walls or features are the major area where the development of the Cura engine was focused on in response to some of the major blockers that we have identified while developing customer application. So, Tobias, what is Cura 5.0 bringing once you are developing application with customers?
Thank you, Andrea, for giving me the opportunity to talk about our use cases. So with the new CC 0.4 millimeter print core, for us it was a natural step for new features and a new way to print thin walls. Thin feature can suffer from void and small gaps, which reduces the stability and integrity of the specific area. Not only in the debinding and sintering process, also in the final metal part, these defects would still be there and could lead to an undesired failure during the application. So printing small details is a very well-known and good application for 3D printing and is now more accessible with better performance. For example, vertical or horizontal holes and of course labeling of parts.
Another source of inaccuracies and part failures was identified by customers when having actually to modify the dimension of the part that they were about to print in order to accommodate the shrinkage of the part during the binding and sintering. Tobias, can you explain why you need to control the part scaling prior to starting the print and why it's so convenient actually to have it in Cura 5.0 and it's already done automatically?
Yeah, let me explain this to you. The new automatically scaling of the parts in Cura 5.0 is an important step towards the reduction of complexity along the process chain. I know it seems to be mysterious for quite a lot of people, but I can tell you it's not scaling. The part prior to printing is not witchcraft. During the sintering process, the metal powder starts to solidify by diffusional processes. The empty areas of the former binder vanish and the volume contracts, leading to a shrinkage. To compensate for this volumetric contraction, the parts need to be scaled prior printing. This corresponds to 119% in X and Y and 125% in the Z direction. Besides the filament composition, which is critical for the shrinkage, also the part geometry can have an influence on the accuracy. Nevertheless, sintering technologies are always referred as near net shape, and an automatic scaling function will help customers dramatically to overcome the first hurdle when starting to print metal parts.
Well, thanks Tobias. Another milestone towards the development of the Cura 5.0 engine capabilities was achieved when Ultimaker and BASF Forward AM started a joint application development with Liber components. In the framework of the collaboration, one category of application that was identified as a target for being produced by Metal FFF were the customized assembly tools, like this one that you can see here. This is a part that fits within the 10 to 12 centimeter size, is a non-standard off-the-shelf part with the need for tolerances within 0.3, 0.4 millimeter over the whole part, and a limited amount of units that needs to be produced per year. Metal FFF was therefore selected as the manufacturing technology to do this cost out, but also to reduce lead time and the whole logistic around the sourcing of this part. Indeed, designing tricky assembly tools requires many efforts and time with conventional manufacturing methods. One of the major challenges that this part was featuring with the former engine version we were using in the past was the fact that the part was showing distortion along some of the thin and high height over width areas after sintering. Tobias, from a processing perspective, which is the origin of the distortion that we have seen in this application?
So, as far as I could understand it, it's based on the crystalline character of our binder, which introduces internal stress along the thermal history of the printed lines in the part, which could also be seen in the phenomena like warpage. In the green state, these stresses are stored, but the matrix resists to the deformation. So during the debinding steps, the matrix is removed and is getting weaker, and the part starts to distort, and the shape is transferred into a full metal part.
So actually, by understanding, therefore, the origin of this distortion, BASF Forward AM and Ultimaker R&D identified in the introduction of the alternate wall directions feature in the Cura slicer a solution to remove part distortions during the sintering process. This feature is now present and used as default settings in the new Cura 5.0 when using both UltraFuse 17.4pH and 316L print profile, giving its key role and the high number of parts and design that requires the alternated wall direction use during print job preparation. As a proof that this new feature is relevant for a broad number of parts, Tobias brought a part today that relates very well with the challenges that we were describing before. Tobias, what is the story behind this part?
This part comes from our very first customer journey, where we did not succeed to meet the desired tolerances, even we did everything right from the state of the art at that time. As you can see, we have high and thin walls, and in the sintered state, it's distorted. As you might remember, you gave us the opportunity to test the feature of alternating wall directions, and it worked on the first print. Since that, we knew it is a mandatory way of printing, which is needed for our material and post-processing.
To conclude, what we have shown today is the beginning of Ultimaker journey into the field of metal printing. As you can see, we are strongly engaged with our ecosystem partners and representing BASF Rödlmeier here today, thanks to Tobias. And we will extend further the capabilities of our Cura engine and hardware to enable users to extend even more the range of metal parts and get an even higher control from printing step till the final sintering step.
Thank you, Andrea and Tobias, for all these interesting insights. So, to summarize, this means that with the new automatic scaling and alternate wall directions feature in Ultimaker Cura 5.0, we will make metal FFF printing easier and more successful. And, as Andrea already mentioned, this is just the start. We are happy to announce that we are working on an exciting new metal 3D printing solution that will use Ultimaker and Cura to unlock more industrial applications. We will reveal more details about this in the upcoming weeks and months. If you're interested and want to be the first one to hear more about this, then please go to ultimaker.com/metal and register yourself for updates. Now it's back to Jürgen for some final remarks.